Hello students, in the class 11 we have discussed the notion of function along with relation, and the function also we have discussed various types of functions like real functions, polynomial function, modulus functions, and identity function, constant functions, signum function. All those functions we have discussed. I think you may recall all those things, but still I will define the function again. Function is a special type of relation. In the last class we have discussed what is relation, and function is also a special type of relation. So let R be a, so in place of R let us put say F be a relation from non-empty set A to non-empty set B, then F is called a function if every element of A has one and only one image in set B. Meaning, let us try with an example. Say A is equal to 1, 2, 3, B is equal to say X. So 1, 2, 3, and this is X, Y. Then 1 is suppose related to X, and 2 is related to X, and 3 is related to Y. Then we call this as function. Now if 2 is related to Y as well, then you see 1 is related to X, 2 is related to X, and 2 is also related to Y. In this case, this is not a function. If we remove this one, suppose say 2 is only related to Y, then we call this is a function. So formal definition goes like this. Let F be a relation from non-empty set A to non-empty set B. F is said to be a function from A to B if every element of A has one and only one image in B, then F is called a function. F is called a function if every element, it should be every element, it should state every element as well as only one image. It has got only one image. In that case, F is called a function. Now, these things we have discussed in class 11. Now, in the class 12, we will try to discuss 2-3 more definitions, types of functions. This one-one function and on-to function. One-one function, on-to function, and one-one on-to functions. So, what are they? First is one-one one function. What is one function? A function from set A to set B. Obviously, these are non-empty sets. Set A to set B is called one if fx1 equal to fx2 implies x1 equal to x2 for all x1 x2 belongs to A. So this is the definition of one function. A function from set A to set B is called one function if fx1 is equal to fx2 implies x1 is equal to x2 for all x1 x2 belongs to A. And next is onto function. Onto function. So let us define it here. Also it is called surjection, and one function is called also injection or injective function. So what is onto function? A function f from A from set A to set B is said to be onto function if for every element y belongs to B, there is one element in A such that f of A is equal to f of there is one element say x in A such that f of x equal to y. In that case, f is said to be onto function. So let us try to understand this more elaborately with the help of some examples. Say this is one set A, this is another set B. So here is, let us take 1, 2, 3, 4. 4 elements are here. So 1, 4, and here some elements are there. Say A, B, C, Now, so 1 is related to A, 2 is related to B, and 4 is related to E, and 3 is related to C. Then this type of function is called 1-1 function. You see, 1 is related to A. That means A has only one pre-image. A has got only one pre-image. Suppose it is like this. Suppose 3 is related to A as well. 3 is related to A as well. That means A has two pre-images, 1 and 3. And 1's image is A, 3's image is A, 2's image is D, and 4's image is E. So this is a function, but this function is not 1-1 function because A has got two pre-images. Although D has got one pre-image and E has got one pre-image. That means if number of pre-image should be 1, in that case it is called 1-1 function. It means, so this is 1-1. This set is, this function is 1-1. Now, but whether this is onto, whether this function is onto, no, because this element does not have a pre-image. This element B does not have a pre-image. If we remove this one, now this becomes a onto function because every element of B has a pre-image. Every element of B has a pre-image. Now, if we remove this C and if we send this one to E, now this is function as well as onto function because every element of B has a pre-image in A, pre-image in A. So this is onto function. But this function is not 1-1 because why? Because 3 has image E as well as 4 has image E. So this is not 1-1 function. So what is 1-1 function and what is onto function? I think it is clear. Now a function is said to be 1-1 onto function if it is 1-1 as well as onto function. 1-1 onto, or sometimes we call this as bijective function or bijection. We call bijection also. So 1-1 onto function. So here we can notice in case of finite sets, if here are say 1, 2, 3, 4 elements, say 1, 2, 3, 4, obviously to this function to be 1-1 as well as onto, here must be also in set B also there must be exactly 4 elements on this, say any, say A, B, C, D, and it may be related to one, may be related to this one may be here, this one here, and this one here. So in this case, this is 1-1 onto function. This type of function is called 1-1 onto function. So let us work out some example whether these functions are 1-1 or onto. We'll check. So f is a function from set of natural numbers to set of natural numbers in such a way that f of x is equal to say x square. Now this is a function, whether this function is 1-1 or onto, let us check 1-1 as well as onto. So for checking 1-1 we write like this, 1-1, we'll check 1-1. So for 1-1 what we have to do, we'll take any two arbitrary elements. Let we consider start like this, fx1 is equal to fx2 x1, what is x1 and x2? x1 and x2 are any two natural numbers in such a way that fx1 is equal to fx2. This implies what? This implies x1 square, because fx is equal to x square, so fx1 is equal to x1 square, and fx equal to x square, so fx2 is equal to x2 square. So this implies x1 square minus x2 square is equal to 0. x1 square minus x2 square is equal to 0. Now this implies x1 minus x2 into x1 plus x2 is equal to 0. So this implies x1 minus x2 is equal to 0. Since x1 plus x2 is not equal to 0, because x1 is what? x1 and x2 are two natural numbers, so sum of two natural numbers cannot be equal to 0. So x1 plus x2 is not equal to 0, so obviously x1 minus x2 is equal to 0. So this implies x1 is equal to x2. So our definition says if fx1 is equal to fx2 implies x1 is equal to x2, then the function is 1, 1. So therefore f is 1, 1. F is 1, 1. F is 1, 1. Now let us check whether it is onto or not. Let us check whether this function is onto or not. For onto, we have to, here from this set n, we have to take any element, say 4. If we take say 4, from here if we take 4, so 4 is image of what? 4 is image of f2 is equal to what? f2 is equal to 2 square equal to 4. So 4 has a 3 image. Now if we take say 3, if we take 3, then do we have any x such that fx equal to 3, x square is equal to 3? Do we have any x such that fx is equal to x square is equal to 3? Answer is no. But x square is equal to 3 does not have solution in set of natural number. If x square is equal to 3, then x is equal to plus minus root 3. So but root 3 plus minus root 3 is not a natural number. So this function is not onto. How to write that? Ontoness, how will you write? Here in this case, one particular example, counter example we call. Counter example will serve the purpose onto. We write like the function is not onto since any element take a 3 belongs to n, but there is no x belongs to n. That means there is no natural number such that fx is equal to 3. So therefore the function is not onto. The function is not onto. Let us take one more example. So fx equal to say fx equal to f is a mapping from say r to say r plus, positive set of positive real numbers, and it is, let us denote it by say x twice x square, something like this. Then same way, how to check the 1, 1? 1 1. We check like this. Let same way. Always we write like this. Fx1 is equal to fx2. We start like this. Always fx1 is equal to fx2 implies x1 x2 belongs to now if we write like this, let us try that fx1 is equal to fx2. So this implies what? Twice x1 square is equal to twice x2 square. So this implies twice x1 square minus twice x2 square is equal to 0. So this implies 2 common. Factorize it, x1 minus x2 into x1 plus x2 is equal to 0. So this implies x1 minus x2 is equal to 0 for x1 or x1 plus x2 is equal to 0. In earlier case, x1 plus x2 could not be 0 because they were natural number. But here it is now real number. So x1 plus x2 may be equal to 0. So here fx1 equal to fx2 does not imply x1 is equal to x2. It may imply x1 equal to minus x2 also. So here this function is not 1 1. So we will show this with the help of an counter. When it is not 1 1, we have to get one counter example. So we are seeing this one, it is not 1 1. So in the examination, we need not write all this. Just once we are sure it is not 1 1, so we will give one counter example. So give counter example like this. Say f of 2 is equal to f of minus 2. F of 2 is equal to 4. Sorry, f of 2 is equal to what? F of 2 is equal to 4 into 2, 8, and f of minus 2 also equal to 8. So f of 2 is equal to minus 2, but 2 is not equal to minus 2. So we'll write in the function is not 1 1 as f2 is equal to f of minus 2, but 2 is not equal to minus 2. So here we show that this function is not 1 1. So if the function is not 1 1, we must create one counter example. With the help of one counter example, we have to show that this is not 1 1. One counter example is enough. So next we'll check ontoness, its ontoness, whether this function is onto or not. How to check? Let y belongs to this set, this is r plus. Y belongs to r plus, so such that y equal to x, y, we put this one, y is x square. So this implies x square is equal to y by 2. So this implies x equal to plus minus put over y by 2, put over y by 2. So this is a real number. This is obviously a real number because y is a positive real number. So positive real number by 2 is again a real number, and square root of real number is again a real number. So is a real number. So so for y belongs to r positive, this one we have got a x equal to r. That means now write like this. Now f of root over y by 2 is equal to 2 into plus minus y by 2 square is equal to 2 into y by 2 equal to y. So f of plus minus root 2 root y by 2 is equal to y. So we have got a x whose value is plus minus root over y by 2 such that f of x is equal to x means plus minus root over y by 2, f of plus minus root over y by 2 is equal to y. So the function therefore the function is on 2. Now if we change here in place of this one plus sign, if it is a set of real numbers to real numbers, in that case here what will happen? Here for negative number, suppose y is a negative number. Suppose y is a negative number, then plus minus root over y by 2 is no more a real number. So in this case, this function will not be on 2. So in that case, we have to create one counter example. So we can say so minus 4 belongs to R, but f of there is no x such that f of x is equal to minus 4. There is no x. There will be no x such that f of x is equal to minus 4. We cannot get an x such that f of x is equal to minus 4. Because if we put here minus 4, then minus 4 by 2 is equal to minus 2. And the square root of minus 2 becomes complex number. So it is no more as element of this set R. So this is not a onto function. But if it is plus, then it is onto function. So in this way, you can solve the exercise 1.2. You can show the functions are 1, 1 or on. Thank you.